Hi, our system is Multiplots for Voice Queries, or MUVE for short, a voice queryable database system. The motivation behind this project has been the rise in popularity of voice querying systems such as Google Home, Amazon Alexa, and Apple Siri. And we wanted to create a system that didn't rely on user feedback to correct ambiguities in the voice queries. In the past, people have created voice queryable database systems, but oftentimes after a first initial query is issued by the user, they would need the user to then go back and correct or clarify on things that the system might not have been sure of. So our plan with our system is to use multiple bar plots on the same screen to give the user an array of results and cover as many possible ambiguities in the query. And so this multi-plot selection, choosing which bar charts should be displayed on the screen, proved to be an NP-hard problem. We implemented both an integer linear program solver and a greedy solver to compare the effectiveness and speed when selecting plots. So if we look at the interface here, in the top left, we'll see this drop-down that allows us to choose which CSV file we want to look at. And so for this example, we're going to be looking at the DOB job CSV file here, which stands for Department of Building Job Filings. And if you'll notice in this data overview box, we'll see some headers within the file that we're looking at. So some important ones we're going to look at are estimate fee, which is the expected cost that the contractor plans the project to take, the initial cost, which is basically how much the city needs, New York City needs to invest upfront in the contractor to get the job done, as well as some other things such as what street the job is occurring on. There's also the name of the person filing listed right down here, the owner of the building as well, and the first name and last name of them. If you'll notice here, you can choose which type of solver you're dealing with, so the integer linear program solver versus the greedy solver, and then in the top right, the three buttons. This blue one here allows the user to speak their query, the green one allows the user to type their query into the box and submit it, and the red one gives user feedback messages. So we'll go ahead and we'll issue an example query to start. What is the maximum estimate fee on 8th Avenue? And so up pops our results here, and we can see that the system, I guess, will make a little bit sense of what the plots actually mean. So if we look at the top here, what this is saying is, okay, all of these charts represent the maximum estimate fee where this specific column is equal to this specific value. So where the value street equals 8th Avenue, the maximum estimate fee was $54,784. So some contractor estimated that would be their fee, and that was the highest that anyone saw on 8th Avenue. And so we can look and see at the bottom here as well, you'll notice the colors, which indicate how sure the system is that the user is looking for that specific piece of information. So red being the highest, that the system is most sure, all the way down to blue, that the system is least sure. And so we'll do one more query here and dive a little bit more into it as well. So we'll say, what is the minimum initial cost for owner Suna? And sure enough, even though the detection was a little bit off in the spelling of Suna, it popped up the correct result that we were looking for. And again, we can see we're looking for the minimum initial cost where the column owner last name equals Suna. So we'll try with the other solver as well, our greedy solver, and we'll click to submit it this time. And sure enough, we still get the same result, which is great to see. And finally, we'll look in our messages here and see that in this specific case, when comparing the integer linear program solver here to the greedy solver, our planning time actually significantly decreases for the greedy solver, which is quite interesting in that it scales a lot better for more complex queries in terms of the planning time. And planning time is how long it takes to select the specific graphs for that specific example. Ultimately, we found that the greedy and ILP solvers both perform well in certain situations. We found that the greedy solver performs well on large input spaces, and we found that the ILP solver performs well on small to medium input spaces where we want a high quality output. Thank you.